Hey guys, welcome to another Code Along. In this video, we're going to continue to build our ship shooter game. In this video, we're going to go ahead and implement collision detection against our enemies, a really simple form of collision detection. This is going to work out our knowledge of loops, and it's going to introduce this concept of loops inside of loops. We call them nested loops. Really powerful concept. So where we left off is we have a little game here. I'm going to go ahead and just refresh this screen where we can move around our little ship and we can hit space to fire our ship. And we have these little squares coming into the screen at random places. We still have that little issue of the stroke going around everything once we fire. We can go ahead and fix that maybe really quick. But we have these little enemies coming down, but nothing happens when the blaster actually hits any of these squares. So what we want to do today is try to implement something that will detect that the actual bullets or the lasers coming out of the ship actually connect with the bad guys or the squares in this example. So let's go ahead and jump over to our code. Now I've included a link in the description below to a public gist on GitHub that has this code in its current state. So if you don't have the code, or if maybe you modified yours and you want to just play a little catch up, that code is available so you can start right where I'm starting from here. So the first thing we're going to want to do, and this actually should be pretty simple for us to do with where we're at, right? So we have our ship, right? At the top of our program here, we have our ship and we have an array of enemies. So we only have one ship in the game, the one we're controlling, and then we have a list of enemies, and that list of enemies kind of just grows over time. We're not really doing anything to remove the enemies from the enemy array, which we probably should do, but that can come later. So in the setup, we're going ahead and doing our typical drawing, creating our canvas, setting our background, and we're creating our ship. And then we're placing our ship directly in the center of the screen. Now, within our draw function, which gets called 30 times a second, we're going ahead and saying, all right, we're going to paint the canvas black on every single draw, and every 100 frames, we're going to go ahead and generate or spawn a new enemy. And we're going to spawn that enemy off the screen, so kind of at the top of the screen, right, in a negative Y position, and then some random X position across the width of the screen. So we have these enemies kind of just coming down on the screen. And then in every frame, and this is where we're going to start to maybe expand this loop a little bit, in every frame, we're then looping through every single enemy, right? We're using this nifty little for loop here to loop through the entire list of enemies, the array of enemies, and then we're going ahead and we're updating the enemy, which is going to update its position. In this case, we're simply just incrementing the Y position, so we're making it go down the screen. And then we are drawing the enemy. In this case, we're just drawing a simple square at that specific X and Y coordinate that we just updated in the update method, right? And then we do the same exact treatment to the ship. So the ship does the same thing. We're updating the ship. When we update the ship, we're seeing what keys were pressed. And we're all doing this in these classes, right? These blueprints that we've defined that define exactly the behavior of the ship. So the first thing we want to do is we want to extend our enemy. Our enemy right now does not have this concept of being alive or being dead in this case, right? So this is where we can get a little creative with how we describe what it means for an enemy to be alive or not. And in this case, all enemies will enter the world breathing life. So they're going to be full of life and they're going to be ready to roll down the screen and possibly attack the ship. So why don't we go ahead and set a property within our constructor here that is going to be a simple true or false value. We'll say this.live equal true. So every single enemy that's spawned by default, right, defined in the constructor, the property will be set to true. So we can use this little variable here to basically decide whether or not an enemy is alive or not, right? So in this case, what we just did is an enemy will pretty much always be alive, right? So if an enemy is alive, we're going to want to maybe draw the enemy in a different color, or maybe we just want to not draw them at all. So I think for now, why don't we go ahead and use this variable to change our draw method a little bit to say, hey, if it's alive, we'll draw it blue. And if not, then we'll draw it, say, red. Right? So let's go ahead here and say fill will be blue by default, but if this.live equal false, then we'll make the fill red. Now, if we go ahead and run the program, we shouldn't see any change because an enemy will never actually be dead. So if we shoot here, nothing actually changes, right? Nothing's going on. But if I go back here, just to prove that this would work, if I say all enemies start or are spawned and they're dead, so we say false here, or they're not alive. So I don't like saying the word dead. It seems a little too strong, right? So they're not alive when they're spawned. And we go ahead and refresh that. Now we should see all of these squares that are coming down the screen are in fact red. So we can see by doing that, we're proving that we are using that variable to be able to toggle back and forth whether or not the actual enemy is alive or not. Right? So I'm going to go back and let's go ahead and switch this back so that our enemy is live by default. And all we really did was we added this line where we said this.live equals true, and we added the conditional here to say if it's live, if it's not live, then make it red. And if it is live, this conditional will never resolve to true, which would just default to this blue color. All right, cool. So now that we have that in place, we now need to detect when we should change an enemy's live property to false. This is where the collision detection comes in. So if we go back up to our draw function up here, we're looping through all of the enemies here. So in order for us to detect that we're actually colliding with a bullet in this case, we need to check the coordinates of the enemy and check the coordinates of every bullet for every enemy. Right? And this is where a little bit of the magic kind of dissipates with this type of program where, collision detection, to me at least, seems pretty magical when you're playing a video game and like it really feels like you're hitting a wall, or it has the hitbox all nice in that video game. Like there's this magical component to making it where it's interactive in that sense, where it's like you're touching something physical when in fact it's just logic in a computer program. So here we are literally in a very brute force fashion looping through every single enemy. And then for each enemy, we're going to want to loop through every single bullet that's on the screen and detect whether or not it's in some proximity, within some distance of the actual enemy. If it is, we can assume that it hit it. So we know that our ship has this idea of bullets. So a ship keeps track of a list of bullets that it has shot, right? And whenever we hit our space key here, we're calling this ship.fire, which is then just spawning a new bullet. The same exact pattern that we're using to spawn our enemies up here. So we know we have a list of bullets. So now what we can do is we can loop through that list of bullets right after we draw each enemy. So right within this for loop, so you want to make sure that you're within the curly brackets of this for loop. We're going to go ahead and define another for loop. I'm going to say for let, I'll call the looping variable j. You don't want to call it I, right? If you call it I, that's going to mess things up royally because I is already declared in the parent for loop that we're using here. So we need to use a different variable name. We need to use, we can call it anything, but typically we have this I, j, and k. It comes from linear algebra, actually. Linear algebra has used these I, j, and k designations in its notations. So we'll say for let j equals 0, and we'll say J. We're going to loop. For how long do you think we're going to loop this for, right? We need to loop for every single bullet in the ship. So we need to access the ship's bullets. And arrays in JavaScript have this nifty little property called length that will allow us to, you just have to spell it correctly, called length. And that will return the length of the list of bullets that are in the ship. And then we're going to open and close the curly brackets. So this is where we have this little nested loop, right? So we have this for loop here that loops over all the enemies. And then we have a for loop inside of that for loop. So for one of these loops, there will be X of these, where X is the length of this list of bullets in the ship. So say, for example, we have 3 enemies and we have 10 bullets, right? For each of the 3 loops that the parent loop goes through, inside of it, it will loop 10 times. So it'll effectively loop through this loop 30 times, right? So within this now we want to get a little fancy, and we want to try to, now we in the scope of this, we now have access to the current enemy, so enemy sub I, which is this index. And we also have an index to each bullet using bullets sub j. Now, with that information in hand, we can actually calculate the distance between these two objects, because each one of those objects have an x and y coordinate. So luckily, P5JS has a nice little helper function here that will do that little bit of math for us. It's called dist. And dist will calculate the distance between 2 points on the graph here, right? So this is a good example. So there's a little example on this page. There's a fixed point here, and we can move our mouse around, and it draws the actual distance of where our mouse is to the fixed point. So you can see that it's calculating the actual distance. So what we want to do is we want to first calculate this distance, and then we want to add a conditional statement using our if statements to say, hey, if this distance is less than some value, say like 8 or 10 or something like that, like really close, right? Then we can assume that that bullet hit that enemy, and then we can set the enemy's live property to false. So let's see what that looks like. So now we're in this loop. And the first thing we're going to want to do here is let's go ahead and define our distance. So we're going to say let distance equals, so we're going to use that dist function. And the first point that we want to test is going to be the current enemy. So this is going to be the enemy's sub I dot x, comma, enemy's sub I dot y. That's the first point, right? So the first point is going to be the point of the enemy that we're currently looking at. And then the second point is going to be the current bullet that we're looking at. So we're going to say ship dot bullets sub j dot x, comma, ship dot bullets sub j dot y. Now, let me just go ahead and move this over. We don't need this here. Now you can see here that we're using that distance function, and we're passing in 2 points, the enemy's x and y position and the bullet's x and y position. So the result of this will be the distance between the enemy, the current enemy, and the current bullet that we're looking at. Now all we have to do is say, hey, if the distance is less than some value, let's say how big, you know what, how big are our enemies? How big is that square that we're making? So the square is, oh, that's not the enemy here, is 20. So why don't we go ahead and make it 20, because we can assume that 20 is going to be around where the bullet is given its size. We'll say less than 20. I'm going to go ahead and open that conditional up. Now, if this conditional resolves to true, then we can assume that the bullet actually hit the enemy. So we could say then this enemy that we're looking at right now, enemies sub I dot live equals false. So now with this code, we should be able to detect and then show by making the enemy red once it actually, we flip this live property to false. Let's see what happens. Let's see if we got this on our first try, or are there syntax errors from mistyping. So we're moving, we're executing. Let's go ahead and fire. Boom! Look at that, it worked. Boom! Now we can adjust the value here a little bit to make it a little cleaner. Ooh, I missed it that time. So now we have a little bit of a game going. So now we could, associate within this conditional, say a score, right? If we hit this, we can maybe increment a score value that we can make a global variable up here to keep track of a player's score and maybe display it in the upper left or upper right hand corners of the screen. We can maybe make the enemies just not draw anymore, right? So maybe if it's we'll move this here and say if it's we can change this around a little bit and say if this is true, then draw. If not, don't do anything, right? And I think ultimately what we should do here is actually remove the enemy from the array, because right now those arrays are just constantly getting bigger and bigger, which is going to cause performance issues if we have a lot of bullets and enemies on the screen that really aren't even on the screen anymore. So that's not a good thing. But now with this in place, let's see what happens. So we're saying we're only drawing if the enemy is actually alive. So now if we go ahead and refresh this, let's let some enemies on the screen. Let's go ahead and shoot them. Boom. Boom. Now what we could do, if we're using imagery or maybe a collection of images, we could actually draw a little animation or something like that, like maybe an explosion or something like that. Right now we're just using primitives to kind of prove out the dynamics of the game. So go ahead and play around with this. Let me know if you have any questions. There's a lot we can do with this. In the next video, what I'd like to do is talk a little bit about making the movement in this a little bit smoother using some really basic physics ideas. Maybe exploring a little bit of force and mass and acceleration and what is a vector and things like that. All right, so any questions, let me know, and have fun. Thanks.